Why we come up with NAT? To reduce the shortage of IPv4 address, guys. Remember the last class. The main logic behind NAT is reducing the shortage of IP address. NAT only allow multiple customer to use same subnet,
Yes, sir.
because ISP
Multiple
routers are
private
not going
address.
to install the private subnet in their routing table. Is my screen visible?
No, sir.
No, sir.
NAT in last class. NAT stands for network address translation. By default, private and public subnet cannot communicate with each other, or private network cannot communicate with public network. Means you cannot access internet with the help of private IP address. Still, your laptop, your mobile devices, all the devices in your home are using private IP address, but they are able to access internet. Reason? My edge device is performing NATing. NAT is running there, right? So NAT is a technology which is used to make communication possible between private and public, or public to private networks. If someone is going to ask you what is NAT in the interview for an example, right? So this is the definition. Technology to translate private IP address into public IP address, and public IP address into private IP address. Public IP address into private IP address, and private IP address into public IP address. And there are three types of NAT. First type of NAT is static
Static
NAT, which is also called one-to-one NAT,
one of you.
right? Which is bidirectional. Bidirectional means you can access internet, and internet can also access you. Means one private IP address will be always translated into one public IP address, and same public IP address can be translated into same public IP address, or public IP address into private IP address. When we are using a static NAT, when you will use a static NAT, when you want internet users should access your private server, right? Internet user should be allowed to access my internal server, guys. For an example, I am providing training for SD-WAN as well, and how my SD-WAN students are accessing my lab. My lab is hosted on a physical server which is located in my room, even in my bedroom, using the private IP address. So how people are going to access my server from the internet? Because my students are on the internet, they all have internet connectivity. So I have configured a static NAT there, right? A static NAT. For the static NAT, I need one public IP address, and I have distributed that public IP address to my all students. And whenever my students are going to browse that IP address, they will get access of my server, because that is the public IP address which is routable on the internet. Routers on the internet in the ISP network can route the traffic towards my network, towards my router. So you can access the public IP address, my public IP address, from the entire world, from the anywhere, if you have the internet connectivity. And when my router is going to receive your traffic, my router will translate the public IP address into private, and after that it will forward to server. Getting my point? Any question? Is there anyone who's not clear
Can you
with a
repeat,
static
sir?
NAT?
Can you repeat again?
A static NAT is one-to-one translation. It is bidirectional, means you can access internet and internet can access you. One public IP address will be always translated into one private IP address, and same private IP address can be translated into same public IP address. So whenever we have a server and we want to provide remote access to internet user, then we'll configure a static NAT, right? Second type of NAT is, guys, dynamic NAT. Dynamic NAT is not in use nowadays. Not in used. We are only using two types of NAT, static NAT and PAT. A static NAT in the company, whenever we have internal server, and that should be accessible from the internet. And dynamic NAT is not in use. Dynamic NAT is many to many translation, which is not in use nowadays. For an example, here in a static NAT, my example can be, let's say 1.1.1 is the public IP address and my private IP address is 192.168.1.1. Guys, question, why dynamic NAT is not in use nowadays? What is the issue with dynamic NAT? Can anyone explain why we are not using dynamic NAT?
Because public IP is very expensive, right? We want to purchase it.
Public IP address is costly, so brother, in the static NAT, in the dynamic NAT, in the PAT, everywhere you need public IP address only. Here in the dynamic NAT, we can have two public IP address for 100 users, for 1000 users, for lakhs of users as well. Many to many means a pool of public IP address. Here we need to purchase a pool of public IP address. Public IP. Let's say from the ISP, I have purchased one public IP address, 1.1.1.0/29. How many IP addresses are there? How many IP addresses are there in this subnet, guys?
6.
3.
6.
6 IP addresses are there, right? Now, for an example, here is one switch, here is one router, and here is the internet. Here is the internet. So, how many public IP addresses are required to connect my LAN to WAN? How many public IP addresses are required to connect my LAN to WAN? 2. 2 public IP. 2 public IP addresses are required. One for my interface, one for ISP interface. Let's say here IP address is 1.1.1 and here IP address is 1.2.2. Now how many free public IP addresses are there? 4. So I can create one pool of that free IP address. Range will be 1.1.1.3 to 1.1.1.6. This is the range of public IP address. I can use it for dynamic NAT. And let's say in the LAN side, guys, 1000 number of users are there. 1000 users are there. Let's say user number 1 is using this private IP address 192.168. The first user is trying to access internet whose private IP address is, for an example, 10.1.1.1. 10.1.1.1. So source IP 10.1, destination IP 8.8.8. PC will forward traffic to router and router is going to translate source from 10.1.1.1 to first IP address from the pool. First IP address from the pool 1.1.1.3. It have assigned this public IP address to this private IP address, right? And router is going to maintain a table, NAT table, where it will bind this IP address. It will make the entry like I have translated 10.1.1.1 into 1.1.1.3. Very good. Now guys, this IP address is in use. This public IP address is in use. How many free public IP addresses are there in the pool now? Total 4 public IP addresses are here. Total 4 public IP addresses are 3, 4, 5, 6. One is in use. How many free IP addresses are there? 3. 3 IP addresses are free. Now when second user is going to generate traffic, let's say 10.1.1.2, again router will use public IP address from the pool. It cannot use this IP address 1.3 because it is already in use. Let's say this user is downloading a movie from the internet, right? So it is going to use another IP address 1.4. When next user 10.1.1.3 will generate traffic, it is going to use 1.1.1.5. When next user 10.1.1.4 will generate the traffic, it will translate this into 1.1.6. When 10.1.1.5 will generate the traffic, then what will happen? Then router will drop the traffic. It will generate a log message
Copy
that
it.
free IP address is not available, space is not available. So guys, if we have 4 IP address in the pool, that means only 4 user can access internet at a time. It doesn't mean that 5th user cannot access internet. If PC1 is going to close the internet session, then 1.3 is going to free now. Now it will use same IP address 1.1.3. But at a time, only 4 user can access internet. This is the disadvantage of dynamic NAT. If we have 1000 users, so out of 1000 user at a time, only 4 user can access internet. Not all 1000 student employees or clients can have internet access. Not possible. Is it clear? This is the disadvantage of dynamic NAT. The space issue. Okay, clear? So earlier we were using dynamic NAT, then we come up with PAT, the third type of netting, that is PAT, many to one. Many to one means many private IP address can be translated into single public IP address. Now here we don't need to purchase slash even 29. Here we can have this public IP address 1.1.1.0 slash 30 slash 30. How many public IP addresses are there, guys? How many usable IP addresses are there in
2.
this subnet? 2, right?
2.
One we will use on ISP side .2 and one I will use on my router .1. Correct?
Yes.
Now this public IP address can be used to translate all the 1000 private IP address. All the 1000 IP address. Question: how it is possible, Praful? Let's say user 1 have generated the traffic. First user 10.1.1.1 and router has translated into 1.1.1.1. Now when second user will generate the traffic 1.1.1, how it can translate into the public? Now where is the public IP address? We have single public IP address which is already in use. So now guys, what it will do, what router will do, router will use the port number for the translation. PAT stands for port address translation. Let's say user has generated the ICMP packet. Which packet? ICMP. ICMP is layer 3 packet. You all know this. In ICMP, we don't have source port and destination port. Correct? So if router is receiving a traffic where port number is not available, then router will use a random port number. You know, port number is 16 bits value. Range can be 0 to 65535. So from that range, it will use random port number. One port number for source, let's say P1, and destination is P2. P2. When second user is going to generate traffic, again it will use same public IP address 1.1.1, but source port is going to be P3, destination port is P4. When next user is going to generate traffic 10.1.1.3, this one is 2, 3, again it will translate the private IP address into same public IP address, but the port number is going to be different, 5 and 6, like this. And when reply will come from the internet, when reply will come, and if the port number, if the source port number is, let's say, P2 and destination port number is P1, it will get to know that, okay, now I'm receiving the traffic where source port is P2, right? And here you can see the entry. Here you can see entry in the NAT table. It will get to know, okay, I am getting reply for 10.1.1.1 because here only destination port was P2. Now I am receiving the reply from P2. That means I need to translate public 1.1.1 into 10.1.1.1. If destination port is P3, then it will translate 1.1.1 into this public IP address, sorry, this private IP address. If the destination port is P5, it is going to translate public IP address into this private IP address. This is called port address translation. Means router is going to translate many private IP address into a single public IP address. And how it is differentiating the table, how it will identify the reply message, that reply message is coming for which source, because for multiple source we have used the same public IP address. So to identify the reply message, it will use port number. Is it clear? So there are three types of NAT: static NAT, dynamic NAT, and PAT, port address translation. In last class I had configured PAT only, and see, PAT is already running on my R1 on router 1. PAT is already running. That's why PC1 should be able to access internet. Let me access it. Let me access the internet from PC1 to verify our previous configuration. From PC2 also, let me say IP 10.1.1.2/24. And what was the gateway, guys? 10.1.1. So IP interface brief. See the LAN interface IP address 10.100. So 10.100, and let me say ping 8.8.8, ping 8.8.8. See, ping is working, and on the router you can see so IP NAT translation. Here you can see the translation, and it is using random port number. You can see, right? 10.1.1.2 is translated into 1.1.1. This is inside global IP address. This is inside local IP address. Inside local is my private IP address. Inside global is my public IP address. Now here is my DNS server. Let me configure the IP address on DNS server. Copy and interface F0/0, no shutdown, IP address, let's say 192.168.10.1 and 255.255.255.0. Exit. Let me disable the routing. No IP routing. No IP routing. And IP default gateway. Default gateway is going to be 192.168.10.100. Right? Let me enable the DNS service IP DNS host, IP host www IP host and www dot, let's say google.com. And what is the IP address of google.com? Let's say web server IP address 192.168.1.2. Done. IP DNS server. DNS service is enabled. Now, can I access this DNS server from this side, from the DC? I have side 1. In side 1, I have DNS server. And what I want, these employees should be able to use this DNS server. So guys, I need one public IP address for my DNS server. I need one public IP address for my DNS server. So instead of using /30 here, now I am going to use /29, because here we need multiple public IP address for one-to-one NATing, because these servers should be accessible from the internet. Internet user should be able to access this server. So let me correct the IP on ISP2 and router 2 on router 2 and ISP2. The subnet mask interface F0/0, no cert is already there. IP address 2.2.2.2. and what will be the subnet mask for /29? 248, right? And
Yes.
then go to router 2, and on router number 2 also I am going to change the subnet mask interface F1/0, no shutdown, and IP address I am going to say 2.2.2.1 and 255.255.255.248. Very good. Now I am going to use one IP address for DNS. My public IP address for DNS is, for an example, 2.2.2.3. So if someone is going to hit on this IP address, my router should forward the traffic to DNS server. Let me configure the static NAT. Go to router number 2, which is my edge router inside one, and say IP NAT source, IP NAT inside source. And what should be the source? It's static 192.168.10.1. 10.1 and inside global IP address, because here you can see it is asking for inside local IP address, guys. Inside local IP is 192.168.10.1 and outside local is inside global is 2.2.2.3. That's it. Now only you need to configure inside and outside interface f0/0 IP NAT inside and interface f1/0 say IP NAT outside. Now from the router number 1, guys, if I am going to ping the IP address ping 2.2.2.3, tell me, I will ping to router 2 or DNS server? Is it going to ping router 2 or DNS server? Ping is not working. First of all, why ping is not working? I am using public IP address here on router number 1. Ping should work. Why ping is not working? Router 2, so IP route. Let me take you to R2 and let me say 2.1 first. This is also not reachable. So IP route static dot is there. Ping 2.2.2.2 not reachable. Go to ISP2. So IP interface brief exclude unassign. IP is 2.2.2.2. That is perfect. Ping and here so IP route BGP. It is learning 1.1.1. Very good. And it should have one default route as well, IP route towards internet. Yeah, default route is also there. Default route is also there. That is fine. And then why ping is not working? R2 and let me say ping 1.1.1.1. There is some issue with the public reachability. Let me check internet router. So IP route through BGP, it is learning 1.1.1 and it is not learning 2.2.2 actually. So IP BGP summary. Here is my BGP configuration and receive route from this neighbor is, you can see, 0. Right, that means there is some issue with BGP on ISP2. So IP BGP summary, one neighbor and it is receiving 1 dot. That is fine. So IP BGP, guys, we are, I think, not advertising 2.2.2 in BGP. Yes, earlier we had advertised BGP like 2.2.2 in BGP with /30. So run section BGP. You can see here. See, BGP is in the BGP we have advertised this subnet with /30. Let me say no to this. Router BGP is number 100 and 2 is running 2 and no to this command. And now I am going to add network 2.2.2. zeros and mask 255.255.255.248. And now you can check. Go to router number 1 and let's ping this IP. Now it's working and now I am going to ping the public IP address of DNS server, this one. So tell me, I am going to ping router 2 or DNS server, guys. See, ping is working. Is router 2 generating reply? No. So IP NAT translation, you can see it is translating 2.2.2.3 into 192.168.10.1. Even on the DNS server you can use debugging command. On the DNS server I can say debug IP ICMP and go to router number 1 and again ping the same public IP address. And now you can see on the DNS server is generating the reply message. Getting my point? So see, all the users from the internet are able to access my internal server now with the help of public IP address. With the help of public IP address, everyone from the internet can access my DNS server. If you are going to hit this public IP address, traffic will reach to router number 2, right? Because this is public IP address and this is routable on the internet. So internet will forward traffic to router 2 and router 2 will translate the public into private and then it will forward to your DNS server. Clear? Ping 2.2.2.3. See, I am getting reply and see the DNS server is generating reply. To whom? To 1.1.1, to the public IP address of DC site. Very good. Very good. From the PC1 or PC2, guys, if I'm going to ping www.google.com, www.google.com, will ping work? No. First, this device should have information about DNS server IP address. That what is the IP address of DNS? So if you will configure the DNS server IP address, then it will send the DNS request. So similarly, now we need to configure this web server, and let's say for web server my public IP address is, guys 2.2.2.4, right? So what I want, if someone is going to hit on this public IP address, router 2 should forward the traffic to this web server. Config T interface F0/0 no shutdown IP address 192.168.10.2 and 255.255.0. Exit. No IP routing. And IP default gateway 192.168.10.100. And go to router number 2 and let me configure one more static NAT here. IP NAT inside source static 192.168.10.2 10.2 inside local IP address and inside global IP address 2.2.2.4. Done. Right now from router number 1 or from PC number 2, you can also ping this IP address .4. See, 4 is also now reachable. You can see, and I am pinging to web server. So if someone from the internet is now going to ping www.google.com, first it will send DNS request to 2.2.2.3, 2.2.2.3, and DNS server will resolve the IP address, and after that it is going to hit 2.2.2.4. Here the private IP address is 192.168.10.1 and here my private IP address is 192.168.10.2. So your private IP address is hidden, guys, hidden. It is also providing one kind of security which is hiding the private IP address. And now we are able to access the private IP address or internal server, private server through internet with the help of public IP address. And router number 2 has permanent entry. This is permanent entry and bidirectional. Here you can see on R2. This is permanent entry. This IP address will be always translated into this private IP address. Clear? Now let me tell you about VPN. Now you can see I am able to access this private servers inside one through the public IP address, right? But guys, these two private subnet cannot communicate. That is not possible over internet and even through NAT. So what we have to do now? Now we have to configure. What we have to do now?
VPN.
VPN. Now what we'll do? Now between router 1 and router 2, we'll create one virtual private network, VPN. VPN is private network, but it is virtual. And how we can create the VPN? With the help of public IP address only, right? Because these two public IP addresses are reachable. VPN. So let me tell you about GRE VPN first. See, from PC2, if I am going to ping 192.168.10.1, ping will not work. This see, destination host unreachable means my default gateway don't have route. My default gateway don't have route. Right? So let's create the VPN now. What will happen, guys, in the VPN? See, what we are going to do here, what is the logic behind VPN is, first of all, VPN is an overlay technology, and you all know the overlay technology. What is overlay? Overlay is a virtual network on top of the physical network. And guys, for the VPN over internet, we come up with technology called tunneling. Tunneling technology. Tunneling is nothing but the technology to create a VPN over internet. Tunneling is a technology to create VPN over internet. Means on router 1 and router 2, we are going to create one tunnel interface, which is the virtual interface. Here I am going to say tunnel interface number 1. Like you create SVI, VLAN interface, tunnel 1, and here also tunnel 1. After that, we'll configure two things here, tunnel source and tunnel destination. Tunnel source, and tunnel source is going to be what? 1.1.1.1, my public IP address, and tunnel destination will be what? Tunnel destination is going to be my remote public IP address 2.2.2.1. 2.2.2.1, and then we'll configure one IP address. Let's say here IP address is 172.16.1.1/24 or /30, any. Similarly, we'll create tunnel on router number 2 also, where I will define tunnel source and tunnel source and tunnel destination. Let me show you. Will configure tunnel 1. Tunnel source is going to be my public IP address, which is 2.2.2.1. Tunnel destination is going to be my remote public IP address 1.1.1, and IP address over here is going to be 172.16.1.2. You can see, guys, IP address on the tunnel interface belongs to same subnet. You can see on both the router. So router is going to install, once I will configure this IP address 172.16.1.1/30 on the tunnel interface. Router is going to maintain routing table. In the routing table, it will make one entry that, okay, there is one directly connected network. Which network? 172.16.1.0/30. Connected on which interface? It is connected on tunnel 1 interface. Getting my point, guys? Now, it will have this information in the routing table. Now, if you are going to ping this IP address, let's say any IP address from this subnet, ping 172.16.1.2, let's say 2. What will happen? Router 1 is receiving a traffic where destination is 172.16.1.2, or you are generating the traffic from router 1, doesn't matter. Router compare destination IP address with their routing table. Router is going to run command show IP route 172.16.1.2, and it will find exit interface. What will be the exit interface, guys? What will be the exit interface for this destination?
1.1.
Tunnel 1.
ICMP. Source IP is 172.16.1.1. Destination IP address is 172.16.1.2. Yes, exit interface is going to be tunnel interface. And guys, whenever router will find exit interface is tunnel interface, router will add one extra IP header called GRE header, and in the extra IP header, in the outer IP header, it is going to add again same information which are available in your internal IP header, means source IP and destination IP. But this time source IP will be what? 1.1.1.1 means tunnel source IP address, and destination IP will be what? 2.2.2.1. Tunnel destination IP address means you can see router 1 have encapsulated the packet, and then router 1 will forward it to ISP1. ISP1 will check outer IP header where destination is 2.2.2.1. Okay, this is public IP address. ISP1 can route the traffic towards internet can route the traffic towards ISP2 can route the traffic towards router 2. Router 2 will again compare destination IP with routing table, and you can see the destination IP address belongs to router 2, guys. So router 2, this is the packet for router 2. Router 2 is going to check now inner header, right? Inner header, and in the inner IP header you can see destination IP address is 172.16.1.2. Again, this is the IP address of router 2. Router 2 will generate reply now. So the main concept and technology is like whenever router will find exit interface is tunnel interface, it will perform the encapsulation, right? Let me show you the configuration first. Here on router number 1, I'm going to create one tunnel, interface tunnel 1, and say IP address 172.16.1.1, 255.255.255.252, let's say, tunnel 1, and then tunnel source is, let's say, fast ethernet 1/0. Either you can define the IP address or the interface, means the IP address which is running on fast ethernet 1/0. And tunnel destination is going to be 2.2.2.1. That's it. And finally IP address 172.16.1.1, 255.255.252, and that's it. Here you can see so run interface tunnel 1. Here is the configuration, guys, on the tunnel 1 interface: IP address, tunnel source, and tunnel destination. So IP interface brief. Here also you can see one tunnel interface is here, their line protocol and status both are up. Very good. And so IP route, in the routing table also you can see 172.16.1.0/30 network is directly connected on tunnel 1 interface. Go to router 2 and let me create the tunnel there as well. On R2, interface tunnel 1 and IP address 172.16.1.2, 255.255.255.252. Tunnel source tunnel source fast ethernet 1/0, and tunnel destination 1.1.1.1. So run interface tunnel 1. See the configuration, and so IP interface brief. And here you can see the tunnel interface status and line protocol both are up. And so IP route. In the routing table also you can see 172.16.1.0 is directly connected on tunnel 1 interface. So from router number 1, if I am going to ping now, ping 172.16.1.2, what will happen, guys? Before forwarding the traffic, let me capture this link to show you the GRE header. Let me capture this link to show you the GRE header, and this is very important to understand the guys, this is not last class, by the way, because we already have the DM VPN. I had forget. The DM VPN is still pending, right? Now let me generate ICMP traffic. You can see ping is working fine, and here is your ICMP packet. Let me open it. See the outer IP header. There are not two IP header. This is my actual ICMP message payload, and then IP header, the actual IP header where source IP is 172.16.1.1, destination IP 172.16.1.2. After that GRE header, and then outer IP header. In the outer IP header, source IP is the tunnel source, destination IP is the tunnel destination. And here you can see the protocol field, source address, destination address, and protocol number GRE. GRE stands for generic routing encapsulation, which uses protocol number 47. ICMP protocol number is 1, right? Here if you will open the ICMP, not ICMP, sorry, IP header, protocol number will be 1, which is the ICMP protocol number. But in the GRE header, you can see protocol number is generic routing encapsulation GRE 47, right? And hope it is clear. Now guys, we have the virtual private network between router 1 and router 2. Here we have the virtual network between router 1 and router 2. Here IP address is 172.16.1.1. Here IP address is 172.16.1.2. Very good. This is my virtual network. Now here on this virtual network, I can configure any routing protocol to exchange my LAN prefixes between these two sites. So let me configure here OSPF routing protocol now. OSPF on router 1 and router 2 for the routing between two LAN. Router OSPF 1, let's say router ID 1.1.1.1 and network, which network? 172.16.1.0. 1.0 wildcard mask 0.0. Let's say 255, not matter. And area 0. Done. On router number 2 also we'll do same thing. Then I will expect OSPF neighborship here between router 1 and router 2. Note over the physical link over the VPN. Router OSPF 1 and router ID 2.2.2.2 and network 172.16.1.0 wildcard mask 0.0.255 and area 0. Now you can see on router number 1 we have OSPF neighborship. So IP OSPF neighbor, very good. 2.2.2 is my neighbor. On which interface? On the tunnel interface. Now on router number 2 I am going to advertise the LAN in OSPF. Router OSPF 1 and network 192.168.10.0 0.0.255 and area 0 and go to R1 and check the routing table. So IP route OSPF. Very good guys. See, side 1 prefix is coming in data center now. And this network is reachable through which interface? Through tunnel 1 interface. So if router 1 need to forward traffic in this subnet, it will perform encapsulation. It will encapsulate the actual payload with GRE header, and in the order IP header, source IP and destination IP is going to be public. Tunnel source and tunnel destination. Tunnel source and tunnel destination. Here on router number 1, I am going to advertise again the LAN network. Router OSPF 1 and network 10.1.1.0 wildcard mask 0.0.255 and area 0. Very good. And now let me check the connectivity between these two sites. Ping 192.168.10.100 and ping is working, and source 10.1.1.100 again ping is working. And in the capturing you can see, guys, let me open this one. See the outer header. Here also you can see source IP address. In the inner header there is actual source and actual destination 10.1 and 192.168.10.100 destination. But in the outer header, every time source and destination is going to be public. Same source 1.1.1, destination 2.2.1. Is it clear to everyone? Hello.
Yes, sir.
Is GRE clear to everyone how we are creating the VPN over internet? Now we know how to create the VPN over MPLS cloud as well as how to create VPN over internet. This is not secure, by the way. Here you can see the traffic is going in plain text, and guys, internet is not secure. Even anyone can see your payload. See, everything is in plain text. Even your password, if you are going to, let's say, access router number 2 through telnet, if you are going to access router 2 through telnet from R1, anyone can see your password. Line VTY 0 and password Cisco. Enable and login. Login and login local. Can anyone tell me the difference between login and login local? What is the difference between login and login local? Enable password is also
Login local means for local database users.
no. Login means it will only ask you for password when you will try to access it, and login local means username and password both are required. Now here I am going to say telnet and let's say 192.168.192.168.10.100. See, I got the telnet access, and here in the capturing you will find the telnet packet as well. You can see the telnet packet. Now if I am going to put the password here, Cisco and Cisco, everyone on the internet can see my password. Enable Cisco. Everyone can see my password here. You can see everything is in plain text. So what we'll do here, we'll secure this GRE tunnel, this VPN through IPsec. Through IPsec, we'll configure will secure this tunnel. But before talking about the IPsec, now let me add one more transport here between these two sites, which is MPLS. Now I am assuming that MPLS cloud is also there. MPLS cloud is also there in my network. Like I have connectivity between two sites through internet as well as through MPLS, and you know how MPLS cloud is going to look like. Like there will be P router, P2P, we will create VPN. It can be L3 VPN or L2 VPN, right? And then customers are going to exchange the routes. Now this time the internet, this internet is, guys, there are two use of this transport, internet transport. I am using internet as a transport as well between the sites, because we are forwarding the private traffic. We are forwarding the private traffic over public network, that is transport, internet transport. At the same time I am using, this is for internet connectivity because we have configured the NAT on router number 1. But for an example, now assume this internet is only providing, this internet is only providing the connectivity. This is my transport, not the NAT. So I'm going to remove the default route from here. No IP and do so, or we can do that later. For now, ignore it. Let me add the MPLS transport first. I'm assuming this is MPLS transport. MPLS transport. Now two transport are there, and MPLS should be my primary transport and internet should be, guys, backup transport, or critical. I want to forward the critical traffic over MPLS and general traffic over internet. I will show you the both, don't worry. Here first of all let me configure the MPLS site. क्या हो जाता है ये को okay. Now MPLS router is up. Let me, this is the VPN. This is the VPN over internet. And which protocol is running? OSPF protocol is running over VPN, our GRE VPN. And our MPLS, let's say we are going to configure the BGP here, and here IP address is, for an example, IP address is here 10.10.1.0/24 or 0/30, and here my IP address is 10.11.1.0/30. Okay. By the way, your MPLS cloud is responsible for reachability between this interface and this interface. MPLS cloud is responsible for connectivity between C to C. You know this already. But here I am going to configure any routing for reachability. Otherwise, we have to add multiple router in the MPLS cloud for the actual implementation. But we already know how we will configure the actual MPLS cloud, L2 VPN or L3 VPN. Let me configure MPLS router first. Config T F0/0, no shutdown, and IP address. IP address is going to be 10.10.1. Let's say 255.255.255.252. Exit interface F1/0 and no shutdown, and IP address is going to be 10.11.1. Again 255.255.255.252. Very good. Done. MPLS router configuration is done. Let me configure R1. IP address on R1 F1/1, no shutdown, and IP address 10.10.1.1 255.255.255.252. Exit. Let me configure one static route here 10.11.1.0 and 255.255.255.0. Exit interface F1/1 and next hop IP 10.10.1.2. Go to router number 2 and let me configure again IP here F1/1, no cert. Doesn't matter how you are making the reachability. Here I have configured the static route. You can configure any routing protocol, or you can add the actual MPLS cloud, the P and C scenario 1.1 255.255.252, and let me say IP route 10.10.1.0 255.255.255.0. Exit interface F1/1 and next hop IP 10.11.1.2. Now from router number 1 I am expecting the reachability. Our MPLS cloud, do ping 10.11.1.1, and you can see ping is working. Let me configure the BGP router. BGP is number 100 and neighbor 10.11.1.1, and remote AS of the neighbor is again 100, and go to router number 2 and let me say router BGP is number 100 and neighbor 10.10.1.1 and remote AS is again 100. I am expecting now BGP neighborship. Yes, you can see BGP neighbor is up. Now guys, I have to transport between branch 1 and branch 2, or between DC and side 1. Between DC and side 1, now I have to transport. Here in the BGP also I am going to advertise the network, LAN network 10.1.1.0 mask 255.255.255.0, and go to router number 2 and here say network 192.168.10.0 and mask 255.255.255.0. Now see, there are two paths to reach side 1 from the DC, but best is via which transport? So IP route 192.168.10.0. Guys, best is via which protocol? Best is via which protocol? Best is via OSPF, because distance value means AD value is what? 110. For IBGP AD value is 200, right? So if I am going to trace route 192.168.10.100 and source 10.1.1.100 numeric 100 numeric 100 numeric. So traffic is going over VPN. You can see my GRE VPN. Next hop IP address is 172.16.1.2 I2 IP address. But what I want to forward traffic over MPLS. So I can increase the AD value of OSPF, router OSPF 1, and let's say distance is let's say 210. And now IP route 192.168.10.0. Now best is via which routing protocol? BGP, right? Now you can see the next hop IP address is this one. Now traffic will go over MPLS. Let me trace route. You can see now your traffic will go over MPLS transport. Here in the simulation it is not working, but we can verify the next hop IP address. Similarly, on router number 2 also we can prefer MPLS over internet. Router OSPF 1 and distance value is 210. And so IP route DC LAN subnet 10.1.1.0 1.0. You can see next hop IP address is 10.10.1.1. Means traffic is going over MPLS transport. Is it clear? Is it clear to everyone? Hope it
Sir,
is.
we can achieve load balancing in the topology.
Yes, you can achieve load balancing, load sharing, not
How
load
is it?
balancing.
Load sharing.
In the production environment, the connection to the MPLS cloud can be made on the private IP.
Yes.
Okay.
Now internet. Now guys, internet, see site to user router from the router number 2. So IP route, if I am going to forward traffic to internet, then traffic is going directly. If I am going to ping 8.8.8, traffic will go to 2.2.2.2, means internet directly. What I want, site to user should access internet via DC. First traffic should go to DC, and then in the DC I have firewall, right? So from the DC, traffic should go over internet. So I will configure default route towards MPLS cloud instead of configuring towards internet. So on router number 2, I am going to remove the default route. First of all, interface F1/0, and here IP NAT outside is running. If you want, you can remove that command as well. Do so run section IP route. There is one default route, right? So I am going to modify the default route. I will say no to this default route. No to this default route. Now if I will remove the default route, then my GRE tunnel bill goes down, guys, because public IP addresses are not reachable. So I will configure one static route for remote public subnet 1.1.1.0 and 255.255.255.0. exit interface is F1/0. next hop IP address 2.2.2.2. again my GRE should be up. We can verify do ping 172.16.1.1, and again there is reachability. And now I will configure one default route, IP route 0.0.0 0.0.0, and exit interface is F1/0, and next hop IP address is 10.11.1.2. very good. Now see, so IP route 0.0.0 or static. Here is my default route. Default route is towards MPLS. Now if the user, let's say this web server is going to ping 8.8.8, if this web server is going to ping 8.8.8.8, then source IP will be 192.168.10.2, and destination IP will be what? 8.8.8.8. it will forward to their gateway. Default gateway means router number 2. Router 2 will compare destination with routing table. There is one default route on router number 2. There is one default route on router number 2. Do so IP route static. Here is the default route towards MPLS cloud. Right? So it is router 2 is going to forward traffic to MPLS cloud. Right? MPLS cloud will forward traffic to router number 1. And router number 1 is going to again compare destination with routing table. Do so IP route and static. And here you can see we have default route towards internet. So router 1 will forward the traffic towards internet. But what we want, before forwarding the traffic, router 1 should perform translation, right? So we will configure one thing here. So run section NAT. Here you can see in the NAT, in the PAT, actually I have used access list number 10 and so IP access list. In access list number 10, we are matching this submit, right? So router is performing translation for this source. Here I am going to modify the ACL, no IP access list 10, no IP access list standard number 10, and IP access list standard number 10, and let me say permit 10.1.1.0 wildcard mask 0.0.255 and the permit 192.168.10.0 wildcard mask 0.0.255. Now these two can be the source. Guys, route is not available in the MPLS cloud. Here we have to configure because we have not configured the L2 VPN. In the L3 VPN, customer have to advertise their prefixes to MPLS P router. Here I am going to configure static route 10.1.1.0 255.255.255.0 and next hop exit interface of 0/0, next hop IP address 10.10.1.1 and IP route 10 dot sorry not 10 192.168.10.0 255.255.255.0 exit interface F1/0 and next hop IP 10.11.1.1. Now ping should work. Let me check. Now you can see ping is working, and if any user from site 2 will try to access internet, you can see internet is still not reachable. Why? On router number 1, let me check. So run interface F1/1. Now the interface facing toward MPLS should be inside interface. Interface F1/1 IP NAT inside. Transport first they should reach DC and then from DC to internet. So what I will do on router number 2, again I will remove the default route. Do so run section IP route and say no to this default route, and this time I will configure default route over GRE tunnel, guys. This time say no to this, no to this, and let me configure IP route 0.0.0 0.0.0 exit interface tunnel 1 and next hop IP address 172.16.1.1 172.16. Tunnel 1 exit interface tunnel 1 and next hop 172.16.1.1, right? And now go to router 1 and on the tunnel interface you can configure inside config interface tunnel 1 and IP NAT inside. And now if the user from the LAN side inside 1 is going to ping 8.8.8, see ping is working and traffic is going fast. DC trace route 8.8.8.8 and source of F0/0 LAN interface and numeric. See, first traffic is reaching to your router R2, then router 1 tunnel interface, and after that ISP1 and then internet. And here I have one more internet connection. From here I have cloud connectivity. Let's say I am my all applications are on this cloud. Let's say this is AWS. This is ISP, and through ISP my AWS cloud is reachable. Here is my some application, cloud application, app 1, app 2, F1 and F2. One has connectivity from two different ISP. Let's say this is ISP 3. Not able to rename because device is on, but you can assume that this is ISP 3, another ISP. Right, so internet should be accessible from here, or these cloud applications should be accessible through this ISP. So on router number 1, we'll modify the configuration on R1. See, now I don't want to route the traffic towards internet, towards ISP 1. So run section IP, and I'm going to remove this default route. No IP NAT outside, and let me configure F1/1. So now you can see on ISP 1 also I can configure the IP, and we can create some loopbacks. Interface F0/0 no cert, and IP address 5.5.5.2.255.255.255.0, and interface loopback 1 IP address 8.8.8.8 8.8.8 and 255.255.255.0. Done. Now go to your router 1 again, and here this interface is outside, no cert. Great. Again you can check from the DNS server, which is the LAN user in side 1, and trace route 8.8.8 numeric. You can see traffic is going to DC. What happened? Why ping is not working? There is no reachability. Let me check. So IP route 0.0.0 reachable via 5.5.5 ping 5.5.5.2. Ping is working, and ping 8.8.8.8. Yeah, ping is working, and then one more thing. So okay, NAT, guys, we have to change the NAT entry. Do so run section NAT. Earlier my outside interface was F1/0. Now outside interface is going to be F1/1. So let me say no to this, no to this. Let me create one ACL. See, we are not able to remove the NAT entry. Why? Because it is in use. Do clear IP NAT translation star, and no access list standard 10. Let me do one thing. IP access list, IP access is standard ACL number 50, and permit 10.1.1.0 wildcard mask 0.0.255 and permit 192.168.10 10.0 while karma 0.0.255. This should be the source. Whenever this source will match in this ACL, then translate it into the IP address which is running on F1/1. IP NAT inside source list 10 and interface F1/1 overload. And let me ping 8.8.8.8 from the source F0/0 interface now. And now ping is working, and go to the DNS server, and here you can ping now or trace.now. Now you can see first traffic is reaching to my DC, and then DC is forwarding the traffic towards ISP, right? So if you have command on routing, then you can route the traffic anywhere according to your requirement, right? Maybe first I want to route site number 100 to headquarter, then headquarter to DC, right? Or site number 10 and 20 should communicate directly. We can have any requirement, and according to your requirement we need to route the traffic. You need to play with routing, right? So this is, guys, VPN. Today we have covered NAT and VPN over internet. In the next class we will see the IPsec, how we can secure the GRE VPN, and after that we'll see the DM VPN.